When we go searching for factors of numbers, we find it pretty easy to see whether a number is divisible by the first prime 2, but to find out whether a number is divisible by the second prime number 3, sometimes, that's a bit more of a challenge, particularly as the number gets a bit larger. But there's a neat little trick, and I suppose what we want to look at right now is how that little trick works. If you look at the number 42 and you ask, is that number divisible by 3? And what we do is we add the two digits. So we'd say 4 plus 2 is 6. And since this number 6 is divisible by 3, then we know that 42 in fact is divisible by 3. That's a little bit strange, because what we're really doing is adding these digits here, where we know that this digit 4 actually represents 4 tens and this digit here represents 2 ones. And so to add them just as they were both representing 1 seems a strange thing. So here's a little video that shows 42 and shows how we can show that it's divisible by 3 if the sum of the digits 4 and 2 are divisible by 3. So let's look again at what we did with the number 42. Notice what we did, that's really 4 times 10 plus the extra 2. But in the video, did you see how we split the 10 into 9 plus 1? So we took the last row off the 10. So if you look at here, we can see, well, I've now got 4 times 9 plus the extra 4 on the bottom, and I've still got the 2. Can you see the 4 plus 2 appearing in here? So we started with 42, but when we split the number this way, you can see that there's the 4 plus 2. So we've now got 4 times 9 plus the 6. And then notice this number here. Is that number there divisible by 3? Well, it is, because 3 is one of the factors of 9 here, and in fact in the diagram you saw that 9 then split up even further into 3 lots of 4 times 3. And of course the 6 is, you saw that as an array of 3 by 2, and so both of these parts that we've split 42 into now, we started with 42 and we've split it up into these two parts, but both of these parts have 3 as a factor. So in fact both of these, this whole number is divisible by 3 because both of its parts are divisible by 3. And so notice it relied on being able to add the two digits, the 4 plus 2, which you can see there. In general, you might have a number a times b. That a there is really 10 times a plus b. That 10 can be split into the 9 plus 1, a plus b, which is 9a plus b. And there you can see there's the sum of our two digits, a and b. There it is. Notice that this number 9a is divisible by 3, so the whole number ab will be divisible by 3 if a plus b is divisible by 3. This reasoning actually extends to numbers of the form ABC, where this would be 100a plus 10b plus c, and then you could say that that was 99 plus 1a plus 9 plus 1b plus c, which is 99a plus 9b plus, and here's the sum of the digits, a plus b plus c. Notice this number here is divisible by 3, because 3 will go into 99. This number there is divisible by 3, 3 goes into 9, so a number in the form ABC is divisible by 3 if the sum of the digits, there they are there, if that number there is divisible by 3. Pretty cool.